Hey everyone, in this AP Chem series video, we're going to take a look at how to write an electron configuration. Remember from the last video, we said that electrons are found in these regions of space known as orbitals, like the s, the p's, the d's, and the f's shown here. Each energy level is composed of certain orbital types, like the first energy level made of a 1s orbital, second energy level with a 2s and a 2p, third energy level with a 3s, 3p adding a 3d, and the fourth energy level which adds one new orbital type, the 4f orbitals. So in this video, we'll take actual atoms like zinc shown here with 30 electrons, and you'll be able to say exactly what orbitals all 30 of those electrons belong to. So doing this is called assigning electrons, and to make it happen we need some rules. The first rule is called the Aufbau Principle, and it tells us that electrons will enter the lowest energy levels first. This also means that we need a tool to tell which orbitals are lowest in energy. That tool exists and it has a name. It's called the Aufbau diagram. It lists the low energy orbitals at the bottom and the high energy orbitals at the top. The nice thing about it is that instead of drawing out all these crazy orbital shapes, it just uses a line. So the 1s orbital represented here with this line, or the 3d orbitals represented here with these lines. So let's talk about my zinc atom with its 30 electrons. Already I can start assigning those 30. The lowest energy level here is the 1s orbital, so that's where the electrons are going to start to be assigned. Here's my first electron. Notice it's an arrow pointing up. The arrow represents one electron and it's pointing up to represent a weird electron property called spin. Don't worry too much about what that is for now, but the first electron you put into an orbital will be spin up, hence arrow pointing up. The next rule tells us that an orbital can hold 2 electrons maximum. That means my 1s orbital that already has an electron, it can take one more. Notice the second arrow to represent the second electron is pointing down. Within an orbital, the electron pairs, one will always be spin up, the second will always be spin down. Now that this 1s orbital is full, I can start moving up the Aufbau diagram to the next lowest energy level orbital. That's the 2s with 1 electron spin up, 2 electrons spin down. Now it's full. I move up to the next set of orbitals, the 2p's. Now for the 2p's, we need one final special rule. It says that when orbitals have equal energy, the electrons will spread out before pairing up. You can see there's 3 separate p orbitals. They all have the exact same energy value. So my first electron will take an open orbital. The second one will not pair up. As long as there's still orbitals that are completely empty, the electrons will go there first. Now that each orbital has 1 electron inside of it, there are no open orbitals to take. The next electrons you can start pairing, pairing, and pairing until the 2p orbitals are completely filled. From here we just move up the Aufbau diagram, first filling the 3s orbital, then the 3p orbitals. Something strange that happens after the 3p's, you might expect to fill the 3d's, but if you pay close attention to the next lowest energy level, it's actually the 4s. So you can jump in and out of different energy levels. First we'll fill the 4s, then back to the 3d's. So there's 2 electrons in my 4s orbital. We've also got to keep in mind that we only have to do this for 30 electrons of zinc. And so far up to the 4s I've used 20. That means there's 10 more electrons to add to my 3d's. Remember, they'll spread out across all these open orbitals first. First 5 electrons each get an open seat, and then the last 5 will start to pair up, making this the final completed Aufbau diagram or electron configuration for zinc's 30 electrons. So let's close the video by saying there is also a handwritten version, sometimes called Spdf Notation, that eliminates the need for this entire Aufbau diagram. Instead of drawing out all these lines and arrows, you simply write 1s with a superscript of 2. The superscript 2 is saying that there's 2 electrons, the same thing these arrows are saying. There's 2 electrons in the 1s orbital. And you just list out all the orbitals with their total electron count the same way you filled in the arrows on the Aufbau diagram. Notice for orbitals like the p's, we lump all of them together, saying there's a total of 2, 4, 6 electrons in each set of p orbitals, stopping with 3d10. These rules and those configurations are some of the key ideas for this video. Make sure you've paused and written them down. That also concludes this video on electron configurations. Thanks for watching, and here is a brief summary.